Have you ever wondered how super-fast machines, like jet engines or the turbines that make our electricity, keep everything sealed up tight? It's not with glue or tape, that's for sure. These machines have parts that spin incredibly fast, faster than the wheels on a race car. If the spinning part, called a shaft, were to rub against a stationary part, it would create a huge amount of friction and heat. That would be a very, very bad day for the machine. So, scientists and engineers came up with a brilliant solution that doesn't involve any touching at all. It's a wonderfully clever device called a labyrinth seal. Think of a labyrinth seal as a secret, tiny maze built right inside a machine. It's a special type of seal that works without its parts ever touching each other. This is super important because in machines like compressors, pumps, and turbines, the central shaft spins at thousands of rotations per minute. Any contact would cause things to wear out, break down, or even melt. The labyrinth seal creates a very narrow, tricky path for any fluid, like a gas or a liquid, that tries to escape. It's designed to make the fluid's journey so difficult that almost none of it can get through to the other side. So, where do we find these amazing seals? They are the unsung heroes inside the most powerful and important machines we rely on every day. You'll find them in the giant compressors that move natural gas through pipelines across the country. They are inside the powerful pumps that move water to our cities or oil from deep underground. And they are absolutely essential in steam and gas turbines that spin generators to create the electricity that powers our homes, schools, and video games. These seals are everywhere, working silently to keep machines running smoothly and safely. The main job of a labyrinth seal is to control leakage. In any machine that handles fluids under pressure, there's always a risk that the fluid will try to leak out from high-pressure areas to low-pressure areas. This is just physics doing its thing. A leak can be inefficient, wasting energy and money. It can also be dangerous if the fluid is flammable or toxic. The labyrinth seal stands in the way, acting like a very clever gatekeeper. It doesn't block the path completely, but it makes it so long and complicated that only a tiny acceptable amount of fluid ever makes it past. What makes a labyrinth seal so special is its design. It's all about creating obstacles. The seal is made up of two main parts, the rotating part on the shaft and the stationary part in the machine's housing. On one or both of these parts, there are a series of sharp, thin fins or teeth. These teeth stick out, coming very, very close to the other surface, but, and this is the key, never actually touching it. This tiny gap, often smaller than the thickness of a piece of paper, is where the magic happens. It's the entrance to our mechanical maze. The real genius of the labyrinth seal is how it uses these teeth to slow down escaping fluid. The teeth are arranged in a series, creating a number of small chambers between them. As the high-pressure gas or liquid tries to squeeze through the tiny gap under the first tooth, its pressure drops and its speed increases, just like when you put your thumb over the end of a garden hose. But as soon as it gets past the tooth, it enters a larger chamber. In this chamber, the fluid expands, its speed drops, and it starts to swirl around, creating turbulence. This turbulence uses up a lot of the fluid's energy. This process happens over and over again. The fluid gets through the first chamber only to face another tooth. It has to squeeze through the next tiny gap, losing more pressure, and then tumbles into the next chamber, losing more energy. Each tooth and chamber combination acts like a hurdle in a race. The fluid has to speed up, slow down, change direction, and tumble around again and again. With every chamber it passes through, its pressure gets lower and lower. It's like the fluid is running an obstacle course that is designed to make it as tired as possible. By the time the fluid has navigated this entire maze of teeth and chambers, it has lost almost all of its pressure and energy. There's simply not enough push left for a significant amount of it to escape from the machine. The number of teeth can be changed depending on the job. For a very high-pressure situation, engineers will design a seal with many, many teeth to create a very long and difficult path. This simple, elegant design allows the seal to do its job effectively without any moving parts rubbing against each other, which means it can last for a very long time. Let's look at a giant compressor, a machine that squeezes gas, like the air that fills a scuba tank. Inside, a labyrinth seal prevents the high-pressure gas from leaking out along the spinning shaft. But it often has a helper, something called seal gas. This is a clean gas, sometimes taken from the compressor itself and filtered, that is injected into the middle of the Labyrinth seal. This seal gas flows in two directions. Some flows back into the process gas, and a little bit flows out toward the machine's bearings. This outward flow acts like a shield, preventing dirty process gas from reaching and damaging the delicate bearings that help the shaft spin. Now think about a big industrial pump moving a liquid, like water or oil. Here, the Labyrinth seal's job is to stop the liquid from leaking out, and, just as importantly, to keep contaminants like dirt and moisture from getting in. If water or grit got into the oil that lubricates the pump's bearings, it would be a disaster. The bearings would wear out very quickly, causing the pump to fail. The Labyrinth seal creates a difficult path for the liquid trying to get out, and an equally difficult path for anything trying to get in, protecting the heart of the machine. In a power plant, a steam turbine is an amazing sight. It uses incredibly hot, high-pressure steam to spin huge blades and generate electricity. Labyrinth seals are critical here. They are placed along the shaft between the different stages of the turbine. Their job is to prevent the steam from bypassing the blades. We want all the steam's energy to push on the blades to make them spin. If steam leaks through a gap, that energy is wasted, and the turbine becomes less efficient. These seals ensure that the maximum amount of power is extracted from the steam, making the whole power plant more effective. The helper gas we mentioned is part of what's called a seal gas system. This isn't just a simple pipe. It's a whole support system with filters, coolers, and controls. Its job is to supply the clean, dry buffer gas to the Labyrinth seal at exactly the right pressure. This system is crucial in applications where even a tiny leak of the process gas would be hazardous, or where the process gas is dirty and could harm the machine. The seal gas system is like a dedicated bodyguard for the Labyrinth seal, making sure it can do its job perfectly under all conditions. So why are these non-contact maze-like seals so important? It really comes down to two big ideas: efficiency and safety. In any machine, efficiency is about getting the most work out of the energy you put in. Wasted energy means wasted fuel and wasted money. In a turbine, when a Labyrinth seal prevents high-pressure steam or gas from leaking past the blades, it forces that energy to do useful work, spinning the shaft. This directly translates to more electricity generated from the same amount of fuel, which is better for the power company and for our planet. Safety is, of course, paramount. Many industrial processes involve fluids that are flammable, like natural gas, or toxic, like certain chemicals. A significant leak of these substances could be incredibly dangerous for the people working at the plant and for the surrounding environment. Labyrinth seals, especially when paired with a reliable seal gas system, provide a robust barrier that contains these hazardous materials. They are a first line of defense, working constantly to prevent accidents and keep the workplace safe. Their reliability is a key reason they are trusted in such critical applications. The beauty of the Labyrinth seal is its brilliant simplicity and durability. Because there are no parts rubbing together, there is very little wear and tear. This means they can operate for very long periods, years even, without needing to be replaced. This long life reduces the amount of time a machine is shut down for maintenance, which saves companies a lot of money and ensures that the services we rely on, like electricity and clean water, are more consistently available. Their design is a testament to how a deep understanding of physics can lead to an incredibly effective and long-lasting engineering solution. In the end, Labyrinth seals are true unsung heroes. They are hidden away deep inside our most powerful machines, working silently and tirelessly. From the jet engines that fly us across oceans to the power plants that light up our world, these intricate mazes of metal are performing a vital job. They boost efficiency, ensure safety, and provide the reliability that modern industry depends on. So next time you flip a light switch, think about the incredible tiny Labyrinth seals spinning at incredible speeds, making it all possible. It's science and engineering at its finest.